It is exactly the same problem that was asked in 2025 JEE. Welcome everyone. Today we are taking up two Savchanko's problem. Both the problems are related, and also it is exactly the same problem that was asked in 2025 JEE Advanced. Now today I'll not be solving the JEE Advanced problem. Today I'll solve these two problems and let you guys do the rest on JEE 2025 problem. Okay, so let's hop onto the problem first. What it says, there is an isolated conducting sphere, okay, which is at a distance of L from a point charge Q, and it is also provided that L is greater than R. The first problem that you can see on the screen, it says if it is isolated, what is the potential of the sphere? Second problem says when it is grounded, what is the induced charge? Okay, great. So when it is isolated, what is the property of a conducting sphere? The potential that it is at throughout the body is same. It's a constant value. So from the surface to the center, a conducting sphere will have same potential, irrespective of whether it has charge or not. That is first. So if that is the case, this cube over this area will have some kind of a variable potential, right? Based on the distance. So how do we determine what will be the exact value? The exact value is kind of, you can say, is the mean that we are taking. What is the mean? Mean is at the center, and we are saying that because the center has this potential, that means the whole sphere will have that potential, and the potential from Q is at a distance L. So we can simply say for this that Vs is equal to K times Q by L. That's it. We got the first question done. Okay. Now let's look at the second problem. It's saying that when it is grounded, what is the charge? So if it is grounded, I'll just connect this up. What is the distinct property when something is grounded? It wants the potential of the body to be zero. Now we already know there is some potential here. That means a reverse potential has to be generated, right? And how it can be? Let's say this charge Q is a positive charge. That means this grounding will actually provide some negative charge on this spherical body, so that this spherical body creates a negative charge. And the positive potential from this point charge and the negative potential because of the charge on the sphere itself will create a zero potential around the system. Let me actually also mention that you can also solve this by using the mirror image method, that you can actually assume that this is providing a charge to a point which probably would be a center. So you can use that concept, but we don't need it. It's a very symmetrical problem. So let's not worry about it. So if the case is grounded, what will happen? That means this has to create a potential. Let's say I have Qs that is created here as a charge. Okay. So if that is the case, that means the potential due to this Qs will be what? On only for the sphere. Let's not worry about this point charge. So Vs would be, it is kind of induced. Okay. The induced, because induced charge, it is collecting from the ground. So what it will be? It will be K times Qs divided by R. But here the total net potential is equal to 0. And what it is equal to? That is because of point Q charge plus Vs because of induced. Okay. So if that is the case, plus what is because of this? That is K times Qs by R. Okay, and that is equal to 0. So what will my Qs will be? Qs will be nothing, but I can simply say minus Q by L into R. So when it is grounded, Vs net, that means the potential, net potential on the sphere is 0. Okay, because of that, it actually got a Qs, which is negative times Q by L of R. Okay, that means if ground is giving it negative charge, that means this is giving positive charge. There is nothing like positive charge, but we can assume it is actually giving back a positive charge here. So that is the simple. And if you look at the first three options from JEE, this will actually solve the first three. Now, the last option which talks about when it is removed from grounding, okay, so if you remove it back again from grounding, what will happen? That means nothing will happen. Still the potential on the sphere will be zero, net potential. But the question says, I move the charge Q by further 10 centimeter away from this. That means the Vs that was due to this point charge on the sphere will change, but the Vs induced will remain the same. So there will again be a potential difference that is created. So the sphere will again get some potential. So on that line, you can go ahead and solve the problem. So it's a very straightforward problem, but only 10% got it correct. So this is what it is. Okay, thank you.